Hello everyone, I'm Wang Ying from Northeastern University. I'm glad to be here to present our work entitled Hero on the Chaos When Paths Meets Modules. This work is collaborated with Nanjing University, HKUST, SASTEC, and Virginia Tech University. In this work, we investigate the dependency management issues in the Golang ecosystem. Go is a young programming language which launched its first release in 2012. Golang allows projects to import and reuse third-party libraries via import paths. The import paths work by matching the URLs of the site hosting the required libraries. Up to now, GitHub hosts nearly 90% Go libraries. However, such a library referencing mode has undergone a major change as the language evolves. Prior to Go version 1.11, library referencing was supported by the Go path mode. Libraries referenced by a project are fetched using Go get command. Developers should manually manage dependencies. There are no dependency configuration script and always fetch the latest library version. To ease the dependency management, developers adopt various third-party tools like deb and glide to manage dependencies and the vendor directory. With the aid of vendor directory, different versions of the library can be managed and downloaded in the local environment. Above all, in Go path mode, the dependency management is rather disordered and takes much developers' efforts. In 2018, Golang introduced the Go modules mode, which allows multiple library versions to be referenced by a module using different paths. First, in Go modules mode, it introduces dependency configuration script Go mode. The Go mode file explicitly specifies the module's dependencies with specific library versions, as well as a module path. With the aid of the module path, the module itself can be uniquely referenced by other projects. Second, the file must be specified according to the semantic import versioning rules. For instance, Golang projects should follow a semantic versioning format. When a project's major version is v2 or above, a version suffix like v2 must be included at the end of its module or import path. It should be noted that such a path is a virtual path. The v2 subdirectory need not to be physically created. Accordingly, to reference the Go modules projects, their downstream project must declare such a path in their Go mode files, as well as in the import statements in their Go source files. For the version 0 or version 1 projects, its version suffix should not be included in its module or import path. During these years, the migration from Go paths to Go modules did not go smoothly, which results in the coexistence of two different library referencing modes. Such means the library referencing modes cause serious dependency management issues. In Go community, developers refer to the capability of recognizing virtual paths ended with version suffix like module awareness. While the Go projects based on latency Go versions typically do not have module awareness. Besides, the DM tools will block the module awareness when projects using new Go versions. As such, we call the Go path project and Go module projects using DM tools as module unaware projects. And the Go module projects do not use any DM tools as module aware projects. The trouble with Go developers is that module-aware and unaware projects differ in passing import paths with or without a version suffix. For example, given an import path like this, the module-aware project will reference the version 0 or version 1 of project A, while the module-unaware project will reference the version of project A on its main branch, typically the latest version. Well, for the import path with version suffix, the former will reference the version 2 plus of project A, while the latter would fail to recognize it. As a result, the Go module is not backward compatible with Go path, causing a crack between these two library referencing modes. Now let's see a real DM issue example. A Go project LZ4 migrated to Go modules in version 207 in order to reference upstream project who had migrated to Go modules. Following SIV rules, it declared the module path with version suffix v2. Although the project can be built successfully after migration, it induced at least the file DM issues into its downstream project still in Go path. Since such module and aware downstream projects cannot recognize the version suffix in the module path. To fix the problem, LZ4 released version 224, which was still in Go modules, but removed version suffix v2 from its module path as a workaround. Obviously, such a module path violated SIV rules. It can resolve the DM issues, but induce the build errors into its downstream project that had already migrated to Go modules. As there is no accurate way to estimate the migration impact to its downstream project, the project developers initiate a vote to determine how to solve this issue based on emojis. Finally, all the developers preferred to rolling back to Go path and suspended such a migration. To understand the chaos caused by missed library referencing mode, we conducted an empirical study to investigate the scale of module awareness among Go projects and learn the characteristics of DM issues. Leveraging our findings, we further developed an automatic tool, Hero, to diagnose DM issues. One interesting feature is that Hero can also provide customized fixing suggestions with the analysis of potential benefits and consequences incurring to the ecosystem. Finally, we evaluated the proposed technique based on real-world projects. To answer RQ1, we collected the top 20,000 popular and active open source Golang projects from GitHub to study their migration status. We found that up till June 2020, only 36% of the top 20,000 projects on GitHub have migrated to Go modules. While among the projects still in Go path, 51% of them depend on DM tools, which block their module awareness. Since DM issues are serious in Go ecosystem, we observed three types of root causes. DM issues can occur when projects in Go path depends on the projects in Go modules, and when projects in Go modules depends on the projects in Go path. It can also happen when projects in Go modules depends on the Go modules projects but violating SIV rules. Of them, type B issues are the most troublesome ones. Type B issues happen because Go path and Go modules interpret import paths in different ways. By reading our collected issue reports, we identified 8 common fixing solutions. Most solutions could affect other projects in the ecosystem, causing undesired consequences. As such, when fixing a DM issue, developers should find a trade-off between the benefits and possible consequences. Now we provide online diagnosis service on our website. Welcome to try out our tool. The Go developers can input a Go project's name and version type on GitHub. Then Hero can automatically provide a holistic view of all the dependencies of the project and the interference between missed library referencing modes. More importantly, if the project suffers from DM issues, Hero will list the detailed root causes and all possible fixing suggestions. To evaluate Hero, we apply it in the real-world Golang projects, and it is submitted to 180 DM issue reports. Most of them are confirmed by developers. Encouraged by developers' positive feedback, we are planning to continuously improve our tool and help build a healthy Golang ecosystem. That's all for my presentation. Thank you very much for your attention.
Good morning once again. This is the you have seen the third video of this session. It is the last one. The video was from Yang Wang from the Northwestern University in China. She has presented a nice research piece of work published in a technical track at ICSI this year. In fact, the paper that is entitled Error on the Chaos When Path Meets Modules got the distinguished SCM 6.
Hello everyone, I'm Wang Ying from Northeastern University. I'm glad to be here to present our work entitled Hero on the Chaos When Path Meets Modules. This work is collaborated with Nanjing University, HKUST, SASTEC, and Virginia Tech University. In this work, we investigate the dependency management issues in the Golang ecosystem. Go is a young programming language which launched its first release in 2012. Golang allows projects to import and reuse third-party libraries via import paths. The import paths work by matching the URLs of the site hosting the required libraries. Up to now, GitHub hosts nearly 90% Go libraries. However, such a library referencing mode has undergone a major change as the language evolves. Prior to Go version 1.11, library referencing was supported by the Go path mode. Libraries referenced by a project are fetched using Go get command. Developers should manually manage dependencies. There are no dependency configuration script and always fetch the latest library version. To ease the dependency management, developers adopt various third-party tools like dep and glide to manage dependencies and the vendor directory. With the aid of vendor directory, different versions of the library can be managed and downloaded in the local environment. Above all, in Go path mode, the dependency management is rather disordered and takes much developers' efforts. In 2018, Golang introduced the Go modules mode, which allows multiple library versions to be referenced by a module using different paths. First, in Go modules mode, it introduces dependency configuration script Go mode. The Go mode file explicitly specifies the module's dependencies with specific library versions, as well as the module path. With the aid of the module path, the module itself can be uniquely referenced by other projects. Second, the file must be specified according to the semantic import versioning rules. For instance, Golang projects should follow a semantic versioning format. When a project's major version is v2 or above, a version suffix like v2 must be included at the end of its module or import path. It should be noted that such a path is a virtual path. The v2 subdirectory need not to be physically created. Accordingly, to reference the Go modules projects, their downstream project must declare such a path in their Go mode files, as well as in the import statements in their Go source files. For the version 0 or version 1 projects, its version suffix should not be included in its module or import path. During these years, the migration from Go paths to Go modules did not go smoothly, which results in the coexistence of two different library referencing modes. Such means the library referencing modes cause serious dependency management issues. In Go community, developers refer to the capability of recognizing virtual paths ended with version suffix like module awareness. While the Go projects based on latency Go versions typically do not have module awareness. Besides, the DM tools will block the module awareness when projects using new Go versions. As such, we call the Go path project and Go module projects using DM tools as module unaware projects. And the Go module projects do not use any DM tools as module aware projects. The trouble with Go developers is that module-aware and unaware projects differ in passing import paths with or without a version suffix. For example, given an import path like this, the module-aware project will reference the version 0 or version 1 of project A, while the module-unaware project will reference the version of project A on its main branch, typically the latest version. Well, for the import path with version suffix, the former will reference the version 2 plus of project A, while the latter would fail to recognize it. As a result, the Go modules is not backward compatible with Go path, causing a crack between these two library referencing modes. Now let's see a real DM issue example. A Go project LZ4 migrated to Go modules in version 207 in order to reference upstream project who had migrated to Go modules. Following SIV rules, it declared the module path with version suffix v2. Although the project can be built successfully after migration, it induced at least a file DM issues into its downstream project still in Go path. Since such module-unaware downstream projects cannot recognize the version suffix in the module path. To fix the problem, LZ4 released version 224, which was still in Go modules, but removed the version suffix v2 from its module path as a workaround. Obviously, such a module path violated SIV rules. It can resolve the DM issues, but induce the build errors into its downstream project that had already migrated to Go modules. As there is no accurate way to estimate the migration impact to its downstream project, the project developers initiate a vote to determine how to solve this issue based on emojis. Finally, all the developers preferred to rolling back to Go path and suspended such a migration. To understand the chaos caused by mixed library referencing mode, we conducted an empirical study to investigate the scale of module awareness among Go projects and learn the characteristics of DM issues. Leveraging our findings, we further developed an automatic tool, Hero, to diagnose DM issues. One interesting feature is that Hero can also provide customized fixing suggestions with the analysis of potential benefits and consequences incurring to the ecosystem. Finally, we evaluated the proposed technique based on real-world projects. To answer RQ1, we collected the top 20,000 popular and active open source Golang projects from GitHub to study their migration status. We found that up to June 2020, only 36% of the top 20,000 projects on GitHub have migrated to Go modules. While among the projects still in Go path, 51% of them depend on DM tools, which block their module awareness. Since DM issues are serious in Go ecosystem, we observed three types of root causes. DM issues can occur when projects in Go path depends on the projects in Go modules, and when projects in Go modules depends on the projects in Go path. It can also happen when projects in Go modules depends on the Go modules projects but violating SIV rules. Of them, type B issues are the most troublesome ones. Type B issues happen because Go path and Go modules interpret import paths in different ways. By reading our collected issue reports, we identified 8 common fixing solutions. Most solutions could affect other projects in the ecosystem, causing undesired consequences. As such, when fixing a DM issue, developers should find a trade-off between the benefits and possible consequences. Now we provide online diagnosis service on our website. Welcome to try out our tool. The Go developers can input a Go project's name and version type on GitHub. Then Hero can automatically provide a holistic view of all the dependencies